All right, this is section 1.3 in AP Pre-Calculus. Rates of change in linear and quadratic functions. Okay. A linear function has the average rate of change over any length. Okay, for any linear function, the average rate of change over any length input is the value interval will be constant. So when we look at a line, the average rate of change will be the same throughout it. We also call that slope with a line. That's the very first one that we ever heard about average rate of change with, and we call that slope. But in pre-cal, we call it all average rate of change, but it's the same thing. All right, now we have a table, and your worksheet will have lots of tables today. But we have a table, and we are looking at this, and we're going to explain. The question says, explain why this is not a linear function. So we do average rate of change over each interval, and the reason that we do that is we can't just look at the table because the table does not have equal intervals. This is not going 1, 2, 3, 4. It went 1, 2, 4, 8. So we have to do the average rate of change for each, like I want to do it for these two. Oops, sorry about that. I want to do it for these two. Then I will do it for these two. Then I will do it for these two, like that. So I did the y values, y2 minus y1 over x2 minus x1. So 7 minus 4 over 2 minus 1 is 3 over 1. Then 10 minus 7 over 4 minus 2 is 3 over 2. Then 13 minus 10, oops, I wrote that wrong. 13 minus 10, glad I saw my mistake. 13 minus 10 is 3. And then 8 minus 4 is 4, so that's 3/4. But regardless, our average rate of change is not the same, so therefore this is not linear. If my average rate of change was constant and the same, it would be a linear function, but it is not. This says consider the quadratic function. And that's what this is a quadratic function. G of x equals x squared. Complete the table of values for g of x over the consecutive equal lengths. Now this is consecutive equal lengths. In other words, I'm adding 2, adding 2, adding 2, adding 2. So these are consecutive. Then complete the table for the average rate of change. Now I can't fit my handwriting in this little box. So I did, first I filled in the table. -3 squared is 9, -1 squared is 1, 1 squared is 1, 3 squared is 9, 5 squared is 25. So I put that in, and then you want to look at how they change. So because my x's are equal measurements apart. So because they're equal lengths apart, I can just look right here and tell what's happening without doing the average rate of change, really. All right, so 9 minus 1, to go from 9 to 8, oh shoot. To go from 9 to 1, I'm subtracting 8. To go from 1 to 1, I'm adding 0 or subtracting 0. They're not, that's how far apart they are. To go from 1 to 9, I'm adding 8. To go from 9 to 25, I'm adding 16. Well, with a quadratic function, the first change in the y values isn't going to show you anything. It's the second change. If my second change is the same, meaning if the change of the change is the same, then it's a quadratic function. So to go from -8 to 0, I added 8. To go from 0 to 8, I added 8. To go from 8 to 16, I added 8. So you can see that my second rates of change are my second change is the same. Therefore, this is a quadratic function. And when I do my average rate of change over there, my average rates of change are not constant. They're not, and so, that tells me something. And so I look at the change of the change, and that lets me know because my change of the change is constant, it is a quadratic function. Now, again, I just did, do not know why I wrote it that way, but it's still right. I went 9 minus 1 over 3 minus negative 1, and as long as I go the same direction, it's okay. I just usually go this way for you, but I went the same direction, so we're all good. So that's 2. And then this time I went 1 minus 1, which is good, and then 1 minus negative 1, which is the way I normally go. So 0 over 2 is 0. And y'all, like I said, the average rate of change is going to be different each time. And that's just what that's letting you see. It's not constant, so it's not linear. So you have to check it to see if it's quadratic, and it is. All right, now this says to determine whether or not, by looking at the table, whether these are linear, quadratic, or neither. So these are equal intervals apart, 1, 2, 3, 4. So when they're equal intervals apart, I can just look to see if there's a pattern over here. Now this is going from 0 to 1, so I add 1. 1 to 4, I add 3. 4 to 9, I add 5. So it's not linear. If I had the same number here, it would be linear. But this one is not linear. So what I do is I look to see if the second change is the same. And if you look, to go from 1 to 3, I added 2. To go from 3 to 5, I added 2. So my second change is the same. This is a quadratic function. Now, looking at this one, notice that my intervals are not equal distance apart. This is not going, okay, this table goes 1, 2, 3, 4 with its x values. This table goes 1, 2, 5, 10. So I have to do my average rate of change to see if it's constant. So 1 minus 0 over 2 minus 1 gives me 1. 4 minus 1 over 5 minus 2 gives me 3 over 3, which is 1. 9 minus 4 over 10 minus 5 gives me 5 over 5, which is 1. My average rate of change is constant, is linear. On this one, these are equal intervals apart. Even though they're not going 1, 2, 3, 4, it's still going 1, 3, 5, 7. They're 2 apart, so I can still just look without doing the average rate of change. All right, so I add 2 to go from negative 1 to 1. I add 1. I add nothing. So then I look to see about the second change. 2 minus 1 gives me 1. 1 minus 1 gives me 0. This is quadratic. Then what I want to do is I want to look to see, are my tables, are my functions concave up, concave down, or neither? So I look at the average rates of change. If the average rates of change are increasing, it is concave up. If my average rates of change are decreasing, it is concave down. I realize some notes were missing here. It's because I wrote, okay. So my average rate of change, if it's concave up, if my average rate of change over equal length over, that's important, let's look at that, over equal length input value intervals, if it's increasing, then it is concave up. If the same thing is the same thing over equal length input values, if it is decreasing, it is concave down. So what I have to do now is I have to do the average rate of change. So I'm going to come over and do average rate of change. 1 minus 4, 1.1 minus 1. Now, y'all, these are equal intervals. But here's my average rate of change. Negative 3 over 0.1 is negative 30. Negative 2 over 0.1 is negative 20. That's increasing. So my average rate of change is increasing. This one is concave up. Okay, so when I do my average rate of change here, I get the same number. This is linear, so therefore it is neither concave up or concave down. Then when I do my average rates of change here, they decrease. So this one is concave down. Thank you.